In this video, we are going to understand what is the reflexive relation and number of reflexive relation in set A if set A have n elements. Dear student, reflexive relation first will define a reflexive relation. It is a relation if a relation R will say like this one, a relation R relation R is said to be reflexive if A comma A belongs in the relation R for all A belongs to set A. What does it mean, dear student? Means all the element, like let's say A, you are taking A1, A2, A3, An, then A1 comma A1 required in in the relation, or A2 comma A2 also required, A3 comma A3, An comma An. Minimum requirement is this one. That meaning is, if we are writing the Cartesian product, then see, it is nothing but one matrix format we are getting. So all the diagonal element, this one is minimum number of element required in the relation R. Then R is said to be reflexive relation. Okay, I hope so this is very clear to you. Okay, after it we are going to count now number of, okay, let's take one example. You'll be getting proper. Let's say A equals to, I am taking 1 comma 2, and B I am taking A comma B, or let's say on A relation R on A such that R is reflexive. So R will be what, dear student? As you are saying A comma A means 1 comma 1 also required, 2 comma 2 also required. Hope so you find it well. If I am taking 3 comma 3 here, let's say 3 another element, so 3 comma 3 also required. If any out of these A comma A, where A is belonging to A is absent, then relation will not be the reflexive relation. Okay, I hope so the definition is very clear to you. Now we'll go for the counting, that how many reflexive relations will exist. Dear student, you are very clear that for reflexive A1 comma A1, A2 comma A2 dot dot up to An comma An has to be there. These elements have to be in the relation R. Okay, means there is only one way that I will be taking all this one. I need to take one way to take all these elements. After this, try to think, dear student. Let's say one relation I made R. So minimum this is required, A1, A2, dot dot up to An comma An. Now let's say take one element A1 comma A2. So either A1 comma A2 I am including in this one, this will be the relation or not. If I am including, then I will be getting the another relation A1 comma A1 dot dot up to An comma An, and I'll be including the element A1 comma A2. Means there are two ways corresponding to the element A1 comma A2. There are two relations corresponding to element A1 comma A2, okay, such that relation is reflexive. How? That A1 comma A2 either it will be in the relation or it will not be in the relation. So using the multiplication rule, similarly I will say either element A1 comma A2 will be in the relation. There are two ways. Similarly, A1 comma A3 will be in the relation. There are two ways. Similarly, dot dot A1 comma An will be relation. There are two ways, and up to dot dot 2 times into 2. It will be how many times, dear student? If you try to see, this is n cross n matrix. Total n square elements are there. N elements are in the diagonal. So remaining element n square minus n. So means either this element will come or not, Similarly, the before of this one element will come or not, total 2 into 2 into 2 will be writing n square minus n time, product of 2 into 2 into 2. 2 into 2 into 2 will be writing n square minus n time, means it is nothing but 2 power n square minus n. 2 power n square minus n. I hope so very clear to you all that number of reflexive relation in set A is equal to 2 power n square minus n. Again I am telling, let's say A equals to 1 comma 2 comma 3. Then number of reflexive relation, you think it like 1 comma 1 2 comma 2 3 comma 3 need to be there, so there are one way that they has to be there. After that either 1 comma 2 will be there or not, okay, either 2 comma 1 comma 3 will be there or not, and 2 comma 3 will be there or not, like any other are remaining, 3 comma 2 will be there or not, okay, 3 comma 1 will be there or not. So it will be 2 power n square minus n. 3 3 is 9 minus 3 6, and these are how many, 1 now more remaining, 2 comma 1, correct. So either this element will come or not, either this 2 into 2 into 2 6 times, so 2 power 6, remaining 3 element out of 9, so 2 power 6 is total number of reflexive relation. Okay, we'll meet in the next video with the number of symmetric relation, and in that one we'll finish all the counting. After that we'll take the questions.